Alrighty, for everyone that decided to be here today, thank you very much. So, class, Angel, thank you for being here. I appreciate you. Alright, so this is actually one of the things called, referred to as Fundamental Theory of Calculus, FTC. You'll see that abbreviated often. Fundamental Theory of Calculus. We use this to actually solve other formulas or other information that's given. So if you know an area, a known area under a curve, you could actually use that to find other parts. So this says that the area under the curve from A to A is going to be 0. What is my delta x? Delta x is 0. So because of this, my delta x, so no matter what my function is, because my area is going to be my f of x times my delta x, right? And that's what we've been doing. But if it's A to A, I should always get 0. And I will show you with an example here in a moment with the reasoning for those. All right. To go along with this next part, it says if I'm going from A to B, f of x dx, I could change that. If this exists, I can go from B to A by changing the sign. All right, so problem that I have, I'm going to take the integration from 1 to 1 of x squared dx. This is where we're actually do the full area under the curve for this. These are definite integrals. When I have numbers right here, those are referred to as definite integrals. There is no plus c, right, Anthony? There's no plus c because it's definite. Because that means you'll see in a second, and I'll show you why, what's going to actually happen. But it doesn't really happen very well on this first one. Let's do the integration of this first. Integration of this. Okay, you said both ones, and then wait. What? I'm trying to show you from this by doing the math. I have to do the math first. Integrate x squared, or antiderivative of x squared. Anthony, what's the antiderivative of x squared? I add 1 to the exponent, right? It's the antiderivative. So add 1 to the exponent and then divide by that number. So it is x cubed over 3 from 1 to 1. Now, we have two separate values here that we're going to use. So when I do this, this turns into top minus bottom. So it's going to be 1 to the third over 3 minus the bottom, which is 1 to the third over 3. Which I end up with just 1/3 minus 1/3, which is 0. I'm going to try this again, but now I'm going to have different integrals. From 3 to 2x squared dx. All right, Angel, since you were paying attention earlier, what's wrong with my bounds here? It says from 3 to 2.
Yeah.
It should be 2 to 3, shouldn't it? But how do I change that? Okay, I'm going to do a negative. So it's going to be a negative, and then I change the bounds, and that's going to be from 2 to 3 x squared dx. Now let's go ahead and do the integration, antiderivative.
Why do you have to put it to negative?
What's wrong here?
I mean, but you can still do it, can't you? The answer would be negative. So what's the point of rewriting it and have the negative in front and then doing it?
Because often you're going to have to do that to actually have it correct. You're going to have different bounds, a different setup. So you're going to have to do this to be able to understand how to change these.
But what's the point?
I'm trying to show that. So from here, I'm going to go with the antiderivative, which is x cubed over 3 from, and there is a negative out front, from 2 to 3. All right, let's do our math by plugging it in. So that's going to be a negative, and it's going to be 3 to the third over 3 minus my upper, or my lower bound right here, which is going to be 2 to the third over 3.
I'm at 810. I'm at 810.
810? Oh, you are? Okay, you're almost ready for 8.
Any help with questions?
Okay. I'm kind of in the middle of teaching here, I know. Yeah. So. All right, so go ahead and put that in. So that's going to be 27 divided by 3 is 9. Two to the third power is 8. 8 divided by 3 is 8/3, right? Okay, I'll just do 8/3. And what do we get there? What was it? 6.3? Whatever the units is on that. Now, the reason for this is actually going to be you have some functions Let's start here. Let's start here. And go here. So let's say, for instance, this function, okay, from 0 to pi, and my function is negative cosine of x. This is the reason for what we did. Yes, this is actually, she was asking why I would actually do something like that. So, this right here, sine is a wave. It's symmetrical, right? Okay, so all the pieces add up together. So area 1 and area 2. So if I do the antiderivative of this, from negative cosine, it's going to give me what? Sine of x, and that's going to be from 0 to,
It should be negative.
should be negative sign? Yeah, you're right, negative sign. Thank you.
Wait, why is it negative?
So if it's negative cosine, integration gives me, yeah, negative sign. Yes. So it goes backwards.
It goes backwards, yeah.
Okay, there we go. All right, so let's do the math on this. So for this right here, it would be negative sine at pi minus negative sine at 0. What's sine at pi? 0. Negative 0 is still 0. What's sine at 0? Now, what's the problem with this? I clearly have area here, don't I? In my graph, I clearly have area here. But what's the problem? Why?
They cancel out, no?
Why do they cancel out?
Because one's negative and one's positive.
Because one of them's negative and one of them's positive. So I need to be able to write this to show that I'm going to have the total area. And how would I go about saying that mathematically this part over here has to be a positive area to get my total area? It's almost like what we just did. To make that into a positive, I would do what? I would take it from, I would have the integration from, because I know this over here is negative, right? And so if I go from 0 to pi over 2, it would be negative, wouldn't it? Okay, but I want to change that. So I can go from pi over 2 to 0, and that would negate it mathematically from my f of x plus the other side of this. What would the other side of this be?
Would that still be 2
It'd be from
2 pi to, or,
pi over 2.
yeah, pi over 2 to pi.
So sometimes when I do this, I have to be able to show mathematically that this is going to be one area, this is going to be another area, and so I could show with an equation using fundamental theory.
But wouldn't they still cancel out?
No.
Would it still be 0?
No.
How would it not cancel out?
Do the math.
Because those areas, because that's still negative though. And they're still equal.
They're equal.
And if one of them is negative, they would have to cancel out.
No, they're not going to. What happened here?
There's still a negative. The negative's just in front.
Okay, but what's going to happen to the area there?
It's going to be positive.
It's going to be a positive area here, right?
Yes.
And what's going to happen over here? A positive area.
Yeah.
Positive and positive gives me.
But there's a negative in front.
No,
It's only in front of this one.
What?
It's only here.
it's sine of 0 minus sine of pi over 2. He's messing with you. It is.
So this right here does not work. Why did this not work? I think what Tree's trying to say is this proves that we clearly have area, but mathematically it doesn't give me area. So you have to be able to show what we did by reversing the bounds to be able to calculate that area and that area. Alright, so we'll continue this if you guys want, but use the rest of this time to actually try and work on your assignments, get your homeworks in, and if you want to keep asking, come up here, do the math.